Alright guys, in this video we are going to put together all the different things that we've learned about trigonometry over the first chapter, Unit 4A, actually Unit 4A and 4B, and we're going to do it on some word problems. So the first question says the angle of depression of a buoy from the top of some lighthouse 130 feet away is 6 degrees. Let's first get some vocab going. Angle of depression. So let's just kind of make sure we understand what that is. Let's say you are up here on a building. So you have some person up here, and they are looking down at some object. Let's just say there's the object. The angle of depression is that angle. It is not this angle inside the triangle. It is this angle here. Now, the nice thing about the angle of depression is it happens to be the same as the angle of elevation, because in geometry you learned that alternate interior angles are congruent. All right? So the angle of depression, anytime you're given the angle of depression, you can automatically assume that it is the same as the angle of elevation, which is inside the triangle. All right? So in this problem, we have, let's redraw it. We have 130 is going to be this distance here. And 6 degrees, I'm going to go ahead and put that right here in the corner. All right, and we are looking for x, this distance right here. And we have a couple options here. We can either do tangent, all right, of 6 degrees is equal to opposite over adjacent, so 130 over x. And we can get the answer there, but you notice that the variable's on the bottom, so we would have to multiply by x and then divide by tangent of x, tangent of 6. However, remember, we've got 6 trig functions, so don't be afraid to use the other ones as well. Remember that the cotangent of an angle is equal to the adjacent side, which happens to be x, over the hypotenuse, or excuse me, adjacent over opposite, so over 130. So now all we need to do is simply multiply both sides by 130, and the 130s will cancel, and if you make sure your calculator is in degree mode, and you will get 1236.87, and that is the distance, horizontal distance from the boat to the lighthouse. All right, we got another word problem here, and essentially we've got a man that is on top of a building. Don't know what he's doing up there, but he is looking down and he sees a car. And the first glance he sees a car and his angle of depression is 22 degrees. A few seconds later, or probably a second later or so, he sees the same car closer to the building and the angle of depression is 46 degrees. And the question is, how far did the car move from when he saw it first to when he saw it the second time? So you can see here that essentially we have 2 different triangles. And so the first is going to be, we'll just say, looks like that's the triangle. And so 22 degrees. And this triangle is made up of some distance x and some distance d, and the height is 100. And so if we use tangent, we would say tangent of 22, tangent of 22 is equal to opposite over adjacent, so 100 over x plus d. Now we've got another triangle over here with a steeper angle, and that angle is 46 degrees, both right triangles, and this is a distance of d. Also 100 is the height, so we have tangent of 46 degrees is equal to 100 over D. All right, so essentially what you have here is two equations with two variables. So we've seen this many times in our high school career. We've got to use substitution. All right, we got to use substitution. So we could have used cotangent of 46 here. That would have left you with D over 100, but either way, solve this for D by cross multiplying, and you get a D that is 96.5689. All right, and there's your D. So take that and plug it in here for D, and we need to do a little bit of algebra here. So it is going to be tangent of 22 degrees is equal to 100 over x plus 96.57. And then we're going to multiply both sides by the denominator. And we'll multiply it over here as well. So x plus 96.57. And so then we're going to distribute this into both of those terms. Here it will cancel. And so we have tangent of 22x. So tangent of 22 degrees times x plus tangent of 22 times 96 is going to give us 39.0164. And that is equal to 100. You're going to subtract the 39 over to the other side, and so you will get tangent of 22 degrees times x is equal to 60.9836. And then you're going to divide both sides by tangent of 22 degrees, divide by tangent of 22 degrees, and you will these will cancel. And your final answer for x is going to be, ends up being 150 approximately. So to be correct, we'll use approximately because we rounded several times. So 150.94 and feet looks like is our units. So that is the answer to this problem. All right, example 3. So we've got a penguin that is connected to the ground using two cables, and the cables looks like they form two different angles, 48 degrees and 40 degrees with the ground, and the cables are attached to the ground. They are 10 feet from each other. So let's see if we can kind of blow this triangle up a little bit so that we can work with it a little bit more. All right, so this distance is 10 feet. All right, now it's important to understand where the angles go. Let's think about it logically. 48 degrees is a steeper angle than 40. So 48 is going to go here, and 40 is going to go right there. All right, and this is our 90-degree angle, and we are trying to figure out how high above the ground the penguin is. So y is what we're looking for. We also don't know x. We don't know the distance the cable is from the building. We just know that the cables are 10 feet apart. That's all we know. They could be 100 feet from the building, 200 feet, we don't know. So once again, this is very similar to the last problem. We're going to have to use two different triangles, a big triangle and a smaller triangle. So we will use the smaller triangle first. So that's going to be tangent. Notice there's a lot of tangents involved. So tangent of 48 degrees equals y over x. And then the bigger triangle is going to be tangent of 40 is equal to y over 10 plus x. So solving, we'll call this equation 1, and we'll call this equation 2. All right, so solving equation 1 for y, when we multiply both sides by x, we get x tangent of 48 equals y. All right, now from there, we are going to now take this and we're going to take this, we're going to plug that into equation 1. Excuse me. No, we're not. Plug it into equation 2. Excuse me. We've already solved equation 1, so let me erase that. We're going to plug this into equation 2. All right? So we're going to replace y with x tangent of 48. So let's see what we have here. We have, working now with equation 2, we have tangent of 40 is equal to y, which happens to be x tangent of 48. And this is divided by 10 plus x. All right, so now we are going to have to multiply both sides by 10 plus x, and that ends up giving us, when you do that, let's just write that out here, 10 plus x on this side, 10 plus x on that side. This is going to cancel. And on the other side, you're going to have to distribute the tangent of 40 in here. Right now, I'm just not going to use a calculator. I'm just going to leave it as 10 tangent of 40 plus x tangent of 40. All right. And on the other side, we have x tangent of 48. All right, so move some things around, and you can do this on your own time, but x ends up being 30.90, 30.9046. Now, that's x, and a lot of students will stop there and they'll think that they got the answer because they've done so much work, but remember, we're trying to find the height of the penguin, so we're looking for y. Now remember, we have already gotten an equation. Maybe we'll call this equation 3, but it's really just the same as equation 1 right here. So now we can just take this x value and plug it in right there. So essentially, y is going to be 30.9 or whatever times tangent of 48. So the final answer for this, for y, is going to be 34.323. And that is the answer to the penguin problem. All right, example 4. This problem can be a little tricky, so we're going to take it slow here. There's something that we need to explain in order for you to understand this problem. Now, notice on this particular video, I am not putting the picture. I know on your notes the picture is there, but eventually you're going to have to know how to draw these pictures without the picture. So I'm going to leave it off and try to make sure you understand the picture in and of itself. So we need to understand that the word course is another word for bearing. So when you see the word course, that also means bearing. And we're going to talk about bearing right now. Bearing is a way for boats and planes to express their location. Boats and planes, all right? So bearing is measured from the north, so it starts north and goes clockwise, all right? This is bearing. So when you see the word bearing or course, you need to measure the angle differently than you normally would. So let's just call that bearing, and let's also write below that, let's say normal. unit circle, maybe. Unit circle. All right? So when you think of unit circle, what do you think? Well, you think starting at 0, and you think measuring counterclockwise. Counterclockwise. All right? So when you see bearing, you have to switch your mindset, and you must start from the north and you rotate clockwise. All right? So let's see if we can sketch this example here. It says a U.S. Coast Guard patrol boat leaves Port Cleveland. So we're going to first start with an XY coordinate. And let's say that they leave at a course or a bearing of 53. Now what does that mean? That means you are starting from the north and you are rotating 53 degrees, which is about there. So the boat is traveling in that direction. Okay? So this is, maybe we're right here. This is 53 degrees right there. All right? And it's going in this direction for 35 miles per hour. That's the speed. And so we'll talk about how to convert that in just a moment. Now, at some point, it turns. So, whenever the boat turns, let me make sure you understand this. Anytime the boat turns or the plane turns, you need to draw a new XY coordinate plane. From there, what you want to do is you want to remeasure the bearing. So now it's saying it's on a course of 143 degrees. So now, once again, you're going to measure from the north, 143 degrees. So here's the north again. So that's 90. All right, and 90 plus 53 is going to be a bearing of 143. So now we see that the boat is going in this direction right there. All right, for 3 hours. So maybe I extend it out a little bit more. And the question is, all right, the question is, what is the boat's bearing and its distance from Port Cleveland? So let's see if we can work this problem out here. 35 miles per hour for 2 hours. That's going to give us a distance of 70. All right, on its first leg. Its second leg, it's going 3 hours, and it's still the same speed, 35. So that's going to be 105. Now you can see this is a right triangle, so you can do Pythagorean theorem. So when you do the Pythagorean theorem to get the distance, you will do 70 squared plus 105 squared equals d squared, and when you end up doing that, you will get a distance of 126.194. So getting the distance away is pretty simple. Now what we need to do is we need to get the bearing. All right, now remember, bearing is measured from the north. So we already know that the boat has 53 degrees right here where I'm outlining. Now what we need is we need to find the rest of this angle here, because bearing is measured from the north. So you rotate north all the way down. So we need to find that obtuse angle. So we know that we can use tangent. So we'll call this angle theta. So we will say tangent of theta equals opposite over adjacent. All right, and so if we want to find theta, we would take the inverse tangent of both sides. Inverse tangent. So theta would equal the inverse tangent of 105 over 70. And that gives us a theta of 56.31. Remember, that is just theta. So if we want bearing, we need to add to that the 53 degrees. And so that gives us a bearing of equals 109.31 degrees. And that is the answer for the bearing. All right, last problem here. And notice that you are not going to be responsible. You would not be responsible for example 5. So we're just going to go ahead and end with example 6 today. And so this is a mass oscillating up and down on the bottom of a spring. And we're assuming perfect elasticity, blah, 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 blah. All right, if the weight is displaced a maximum of 5 centimeters, find the modeling equation if it takes 2 seconds to complete one cycle. All right, so what did it just give you in that last sentence? 2 seconds to complete one cycle. It gave you the period. Period is 2 seconds. All right, and we know the formula for the period. The period formula is 2 pi over b, and that equals 2. So cross multiply, and we'll just make this 2 over 1, so 2 pi equals 2b, and we can divide by 2, so b equals pi. So b equals pi. All right, so we know that when we write our equation, b must be pi. It also says that the weight is 5 centimeters. It's being displaced a maximum of 5. So there's your amplitude. All right, so if it's in the center, it will go down 5 and up 5, and you can see the picture. So the amplitude, will say the letter A, will be 5. All right, so now the question becomes, do we use a sine or a cosine curve? Technically, in this problem, it does not say where the spring begins. Does it begin in the center? Does it begin at the top? Does it begin at the bottom? It does not specify. So if it doesn't specify, you are free to choose to use either sine or cosine. However, in this case, I'm going to assume that the spring starts at the bottom. So when time is 0, the spring starts at the bottom, only because I'm imagining this spring being pulled downward to its lowest value and then let go so that it just springs up and down. So if it starts at its minimum, we know that that's going to be a reflected cosine, because remember, the cosine curve, let's just review, starts at its max, halfway through it's at its minimum, and it ends at its max. So there is the regular cosine. The reflected cosine is going to start at the minimum, maximum, minimum. So there is your reflected cosine or negative cosine. So I'm going to write it in this way. The height of the spring at any time t is going to be negative 5 cosine of pi t, because b is pi, and that is your answer.